Good day, viewers. My name is Dr. Chris. I hold a doctorate degree in mathematics. I'll be bringing another topic in statistics to you again today. Today's topic, we shall be looking at how to create a frequency distribution table. In a situation where you have a huge data that are voluminous, up to maybe the sample size maybe up to 50, 100, how do you now summarize them in a frequency table so that you can have easy analysis? Once again, I want to welcome you to my YouTube channel, Dr. Chris Mathematics and Statistics channel. Please subscribe to my YouTube channel, like my videos, share them on your social media platform, on your WhatsApp status, your Facebook, and again, I want to also plead with you to click on the bell button so that you can subscribe, so that anytime I upload a video, you will be the first to get a notification. So today we shall be looking at how to create a frequency distribution table when a set of data is large. For instance, look at the set of data we have on the board here today. Is sales data from a firm for 30 days. These data have been recorded for the past 30 days from a sales firm. Now, if we want to carry out analysis using this data, it may look a bit cumbersome, it may look a bit tedious because they are a bit large in number. For instance, there are data that can be larger than this. You have this sample size maybe up to 80, 100, some 500. How do you now group them in a frequency distribution table? Now, the solution to this is very simple. The first thing you do when you come across data set like this, trying to create a frequency distribution table, the sample size here, N, the sample size here, N, is equal to 30. The first thing again that you look at, you look for the highest value. The highest value here is 40, while the lowest value is equal to 6 from the set of data. This is the first thing you do. You look for the highest value, you look for the lowest value, then you now calculate what we call the range. The range is the first thing you need to know. So the range arrow is equal to the highest value minus the smallest value, and this is equal to 40 minus 6 and is equal to 34. After you have done this, the next thing is to determine the class size. The class size C will now be chosen. It depends on the range and it depends on the nature of the data. It depends on the space within the data set. That will determine you, that will now give you it will give you the idea of what the class size should look like. Like for instance now, if I choose a class size of 3 here, 3, if I divide 3 by 34, I'll be having 11 points, close to about 12 classes, which is too much for this set of data. If I divide it by 10 also, I'll be having 3.4, which is about 4 classes, which is also too small. So you choose your class size in a way that the number of classes will not be too small and the number of classes will not be too much. So for this particular problem, I have chosen the class size to be 5. So it is now easy for us to calculate the number of classes. Now, number of classes, which is called K, will now be equal to the range all over the class size, and that will be equal to, the range is 34, all over the class size we have chosen to be 5. We chose 5 because it will give us a better number of classes. Now, if you choose 10, you have a very low number. If you choose 3, so you look at it in a way that you do it moderately. Now, I have chosen this. This will be equal to 6.8. 6.8. Of course, we round it up to the whole number. Nearest whole number is approximately 7. So for this data set, we are expected to have 7 classes. K is the number of classes, while C is the class size. Then the lowest value here is 6 from the data set. The number of observations, the sample size is 30, while the highest value is 40. So the class size can be chosen at will, depending on what your range is and depending on what the data set is, the spacing in the data set. So and you choose it in a way that you will not have too many number of classes or too few number of classes. You choose it moderately. So you have the power to choose your class size. But in a situation where the class size is given, you make use of what is given. But when it's not given, you have the power to choose and choose it wisely. Now we will go ahead to create our frequency distribution table using the tally system. We are going to make use of the tally system to create our frequency distribution table. If you have taken note of what is written here, I will leave the data. Permit me to clean this part of the board so that we can create our frequency distribution table. Remember, your class size is 5. The number of sample and the number of classes is 7. So now I will have my class and I will have my frequency. The first class will start from the smallest value, the lowest value, which is 6. So it's starting from 6 to 10. Why 10? The class size is 5. The difference between 6 inclusive, between 6 to 10 is 5. You count it 6, 7, 8, 9, and 10. So the second class will start from 11. You are not permitted to start the second class from 10. Because if you start the second class from 10, you have 10 here, you have 10 here, and you have 10 in the data set. Where are you going to place it? So this one will now start from 11 to 15. Then the next one will start from 16 to 20. Then the next one will start from 21 to 25. Then the next one will start from 26 to 30. Then the next one will start from 31 to 35. Then the next one will be, of course, from 36 to 40. We have to stop here. Why? The highest value is 40. So the lowest value is 6. So these classes cover the entire data set. Now we can make use of the tally to get the various frequencies. It's very, very important. Now my first data here, let me roll a line so that we'll be able to differentiate them clearly. Good. So having this, we are going to start. We are going to start in this order. The first value here in the data set is 22. Look at how I use my tally system to get the frequencies. Where does 22 fall? 22 falls here. So I put 1 here, I tick it. You have to tick it so that you don't do it twice. The second one is 20. Where does 20 fall? 20 falls here, I put 1, I tick it. The next one is 14. Where does 14 fall? 14 falls here, I tick it. The next one is 16. Where does 16 fall? It falls here, I tick it. The next one is 11. 11 falls here, I take it. The next one is 26. 26 falls here, I take it. The next one is 34. 34 falls here, I take it. The next one is 28. 28 falls here, I take it. The next one is 40. 40 falls here, I take it. The next one is 18. 18 falls here, and I take it. The next one is 29. 29 falls here, I take it. The next one is 18. 18 falls here, I take it. The next one is 24. 24 falls here, I take it. The next one is 10. 10 falls here, I take it. The next one is 23. 23 falls here, I take it. The next one is 17. 17 falls here. This one is already 4, so we cross it. 17 falls here, I take it. The next one again is 17. It falls here, I take it. The next one is 6. 6 falls here, I take it. The next one is 13. 13 falls here, I take it. The next one is 15. 15 falls here, I take it. The next one is 24. 24 falls here, and I take it. Then the next one is 30. 30 falls here, I take it. The next one is 23. 23 falls here, and I take it. The next one is 37. 37 falls here, and I take it. The next one is 12. 12 falls here, and I take it. The next one is 16. 16 falls here, and I take it. The next one is 20. 20 falls here, and I take it. The next one is 19. 19 also falls here, and I take it. The next one is 38. 38 falls here, and I take it. While the last one is 8. 8 falls here, and I take it. Remember, we have 30. So what we are going to do now, from here, we are going to count the frequency, F. We are going to count the frequency. Remember, when you are using the tally system, when you count 4, for you to count the 5th one, you have to cross it. Now let us count. This one is 1, 2, 3. The frequency here is 3. Now let us count this one, 1, 2, 3, 4, plus the crossing, 5. Let's count this one, 1, 2, 3, 4, 5, 6, 7, 8, 9. This one is 9. This one is 1, 2, 3, 4, 5. This one is 5. This one is 1, 2, 3, 4. This one is 4. This one is 1. And this one is 3. And at the end of the day, if you sum the frequency, you are expected to get 30. 3 plus 5, 8, plus 9, 17, plus 5, 22, plus 4, 26, plus 1, 27, plus 3, 30. So this is how we have grouped this data from ungrouped data to group data. There are other things that you need to know about a frequency distribution table, because a whole lot will be analyzed from it. You need what we call the class boundaries. The class boundaries are very, very important when creating the frequency distribution table. For instance, this class has the lower part, which is 6, and an upper part, which is 10. What you need to do when you are calculating the class boundaries, you subtract 0.5 from the lower class and add it to the upper class. So for this one, you are going to have, when you subtract 0.5 from 6, you are going to have 5.5. You are going to have 5.5 to 10.5. Then you are going to have 10.5 to 15.5. Here you are going to have 15.5 to 20.5. Here you are going to have 20.5 to 25.5. Here you are going to have 25.5 to 30.5. you are going to have 30.5 to 35.5. Then here you are going to have 35.5, 35.5 to 40.5. It is from these class boundaries you'll be able to see the class size clearly. Some authors call it class width. Look at it now. 10.5 minus 5.5 is 5. 15.5 minus 10.5 is 5. 20 over like that, you will be able to see the class width there clearly. And again, another thing that you need to know from the frequency distribution table is what we call the cumulative frequency. We have the cumulative frequency. Calculating this one again is very, very important because we will need this to calculate the measure of position, like the quartiles, the deciles, the percentiles. You also need it to compute the median. So the cumulative frequency column is also very important. I will start with the first frequency here, which is 3. This will be 3. The next one will be 3 plus 5. You add this to this next frequency, which is equal to 8. Then the next one you add 8 plus 9. You add it to this 9, which is equal to 17. Then the next one you add 17 plus 5, and that is equal to 22. The next one you add 22 plus 4, and that is equal to 26. While the next one you add 26 plus 1 is equal to 27. Then the last one you add 27 plus 3 is equal to 30. That is the sum of the frequencies. You must arrive at the sum of the frequency. If you don't arrive at the sum of the frequency, then you know that your estimation is wrong. Then again, this will now take us to the percentage of the frequency. All these things are necessary in the frequency distribution table. It will give you a pure understanding of what the frequency table is. Now we are looking at percentage of the frequencies. Percentage of the frequencies. And so we are putting them in percentage like this. The first frequency there is 3, and the sum is 30. So you are going to have 3 divided by 30 times 100 over 1. So when you carry out this calculation, you have 10%. It means this frequency of 3 has 10% of the entire frequency, which have sum of 30. Then the second frequency is 5 over the total frequency, 30 times 100 all over 1. Remember, we are rounding up to the nearest whole number, and this will give us 17%. Then the third one is 9 upon 30 times 100 all over 1, and that will give us 30%. Then the next one is 5 upon 30 times 100 over 1, and that will give us 17%. Then the next one is 4 over 30 times 100 over 1, and that will give us 13%. Then this one is 1 over 30 times 100, and that will give us 3%. While the final one is 3 over 30 times 100 over 1. Of course, that will give us 10%. So this is what we have here. We have put the various frequencies in percentage. And if you have the sum, if you sum the percentages there, you will get a whole sum of 100. 10 plus 17, 27, plus 30, 47, and you add like that, plus 17, plus 13, plus 3%, plus 10%. Altogether, you are going to have 100%. You're going to have 100%. It's as simple as this. So this is how, even if the data sets are 500 in number, even if they are 600, even if they are 100 in number, this is how it goes. You first of all calculate the range. You know the highest value that will guide you properly. You know the lowest value. If you guide you properly, then you calculate the range. The range is the highest value and there's the smallest value. Then from there, you will now choose your class size wisely, depending on the spacing and the data set. Then when you choose that, you divide to get the number of classes. You divide the range by the class size you have chosen wisely, and then you will get the number of classes. You say, remember, we got 7 as our number of classes. Let us count the number of classes. 1, 2, 3, 4, 5, 6, 7. So we have 7 number of classes. And the class weight, you will see it from the class boundaries. 10.5 minus this, you have 5. 10.5 minus 5.55, 15.5, you will see it clearly in the class boundaries. So this is how we create a frequency distribution table. If you can do this, then you can work with a large amount of data, whatever research you are doing. So you choose your class size wisely. So I want to plead again with you to subscribe to my YouTube channel, Dr. Chris Mathematics and Statistics channel. Try and share the link of the various videos to your social media platforms, your WhatsApp, Facebook, and the rest of them, so that more viewers can know the good thing that is happening here. Also, click on the bell button so that you will be notified anytime I post a video online. Like the video and share it to your friends and your loved ones. I will be coming again in our next class. I will be talking extremely on the measures of central tendency. The measures of central tendency. We have the mean, the mode, and the median. We'll be looking at mean, mode, median for grouped data, mean, mode, median for ungrouped data. This is an example of grouped data. The difference between group data and ungrouped data is not that there is any much difference. It's just because when data are very bulky, when data are very large, we put them in a frequency distribution table. We group them in this way, and we can be able to calculate the measure of central tendency, like the mean, the mode, and the median. We can even calculate the measure of location, the deciles, the percentiles, the quartiles. We can also calculate the measures of variability or measures of dispersion, like the standard deviation, the variance, the mean deviation, the range, and so on and so forth. So we'll be looking at that one after the other. If you have been able to create a frequency distribution table from a huge data set, it's a very huge success. Remember the criteria followed. You follow it. If your frequency distribution table is faulty, there is nothing that you can calculate from it that will be correct. So you need to get a right frequency distribution table. So this represents this set of data. Look at it now. For instance, if I want to calculate the mean, the mode, and the median from this set of data, that is 30. You will know how stressful it's going to be. Going to add the 30, divide by 30. If it is the median, you're going to arrange from the smallest to the highest, order in ascending or descending order, and so on and so forth. But this one with class, this frequency distribution will help us with the formula summation f of s followed by summation f to obtain the mean. Quickly, the formula for the mode is there. The formula for the variance, for the standard, the variance for the mean, mode, and median, they are there. Also variance, whatever thing you want to calculate from here, it can be done. So take note of this data set. We are going to be using it for mean, mode, and median, where we are looking at mean for group data. It's an example of a group data. From the ungrouped data, their individuality, we have been able to group it. That's what we call the frequency distribution table. Once again, thank you for watching today's video. I hope you will endure to wait for the next one that will be coming up shortly. Measures of central tendency, the mean, the mode, the median for group and ungrouped data. Please subscribe to my YouTube channel, like my videos, click on the bell button so that anytime I put a new video online, you will have the notification. Share it on your social media platform so that your friends will know what is going on. There is no discipline that doesn't need at least a course in statistics, especially this introductory part of it. God bless you. Thanks for watching. Have a great day. Bye.